All right, guys, Mr. Midas is here. I'm here with my last example on using the first derivative test. So I was cut off on the last one. I only had about 15 minutes, so this one's going to be kind of short. I only have one example here. So let's go and take the derivative here. Notice this is a polynomial. Oops, I didn't want to use red. This is a polynomial, so we don't have any domain restrictions. So we'll take the derivative. We get 3x squared minus 6x plus 3. We'll go and factor the 3 out, and we'll get 2x plus 1. And that'll give us 3 times x minus 1 squared. We'll set that equal to 0, and we'll get 1. So we've got one critical number right here at x equals 1. So we'll go ahead and make our chart, our number line. And there's our 1. And we're going to go and plug in something else. So let's plug in 0 and 2 into our derivative. When we plug in 0, we're going to square it. That's going to be positive. When we plug in 2, we're going to square it. That's also going to be positive. So our f function is going to go increase and then increase again. But the derivative is 0, so that tells us that the slope of the tangent line is in fact going to be horizontal. So if it's going to increase and increase, it's probably going to look something like that, where it flattens out. That's a horrible drawing, guys. Goes up and it flattens out and then it comes back up. Okay, this is a flat. Okay, it comes back up like that. So if this happens, then where are we going to have any relative mins or max? Are we going to have any extrema? No. So there's no extrema here. In fact, increasing, f increases for all real numbers, since f prime is greater than 0 for all x values. So if this happens, this is called a strictly monotonic function. Okay, you don't have to know that word, but this is called a monotonic function. Basically means that this function is always going to increase or it's always going to decrease. And this is interesting because really what it shows us is that even though we got a critical number, it's not always going to be a relative min or max. It could just produce that instance where we have a slope of the tangent line that is 0, but still have an all increasing function or an all decreasing function. So it's really important to note that even though we get critical numbers, or even though we have critical numbers, either that the domain is undefined or the slope is 0, it's possible that f doesn't change from increasing to decreasing. So we want to make sure we go through the motion here and we actually figure out whether or not it's going to be positive or negative on each side of this critical number, because we might end up with some monotonic function. All right, so that was my last example of using the first derivative test to find where the function is increasing or decreasing. Catch you later, guys. Bye-bye.